Every day, the future's getting closer.
Welcome to Master the NEC, where we talk about the National Electrical Code and all things electrically related. My name is Paul Abernathy, your host, and welcome to today's podcast. Well, hello everybody. Welcome to another episode of Master the NEC, where we talk about the National Electrical Code and all things electrically related. My name is Paul Abernathy, your host as always, and welcome to the podcast. All right, so today's podcast, kind of leading up to this, is going to be what I consider controversial because it causes great debate amongst individuals, some of them that are very close to me, very close friends, as well as others. And so what we're going to do today is just kind of give you a podcast that explains a little bit about a concept, but it's also going to allow you to make your own mind up because, again, the way the National Electrical Code is in some cases, it's really interpretation. And so I really, through the years, have learned that one person can think they know more than the other person or whatnot, but at the end of the day, we all know a little bit of something about something, and everybody has an opinion. Opinions being what they are, it's perfectly okay to have your own opinion of certain things. And, you know, we can be stubborn and not want to accept other people's concepts or opinion. And we see that with politics all the time. So, again, it rolls over also into the electrical industry when we look at the National Electrical Code and one person thinks they know more than the other, and they maybe they do. I'm certainly not a know-it-all. But somebody may, so we all have to form our own conclusion based on the evidence that's given. Plus, sometimes we have to back it up with some science. And one thing about the National Electrical Code is there's a thing about being in print, and we know that the National Electrical Code can't tell us everything. So, some of the areas are gray area, and I hate to say gray areas, but it is. And it really is depending on your jurisdiction. And jurisdiction has the overall authority. And that's something we always have to remember. Although we don't want to give them the authority to do something that can end up being unsafe. So when we come up with concepts of the way we interpret the National Electrical Code, which is a minimum safety standard, and then the local jurisdiction does something, we also have to understand that we're all on the same page when it comes to safety. Okay, minimum safe. Now, something can be argued that it's fact in the code the way it's written, but it could be interpreted a different way. There's many people that use this document. But when we talk about facts, there's an aspect of what is fact versus what is interpretation of that fact. And so we're going to look at all those today and kind of discuss something, because to me it's an important topic that's about ready to get, to me, a little more complicated in the 2020. So, at least of how the concept is. Now, first things I want to talk about is research first. And I haven't even told you the topic today, and that's on purpose. Okay, so just hang with me. So, after a lot of review, reading, looking, talking, working with people that I consider mentors and other people that are high up in the industry, I mean very high up in the industry, and well as other authors and friends and everything. Of course, I have my own opinions and my own conclusions. I've come to the conclusion on something that we're going to talk about today. But again, I'm going to make sure that you understand that we're really trying to achieve safety. So there is some rule of thumbs that people tend to follow. But we're going to examine why you would do that and why is that important, or why does it risk safety to do that, or why you wouldn't do something. So with all that cryptic talk, what we're going to talk about today is paralleling. And we're not going to dig so deep into the concept of phase paralleling, but we're going to talk probably more about equipment grounding conductor paralleling and the concept of paralleling in some of the terminologies, and it's kind of give you an overview. Now, you can make your mind up. Everybody is allowed to make their own mind up in this and do it as you deem fit, as long as your HJ is okay with it. But you have to be intelligent enough to look at the other side and say, well, this kind of makes sense. Now, I will say that my opinion on this subject today, personal opinion, is in line with a lot of heavy hitters. Okay, when I say heavy hitters, I'm talking about people that develop, who actually go a little bit above the code making panel level. Okay, not necessarily an endorsement by any association, but just kind of they align. And of course, there's some that people that I highly respect who disagree with me, and that's okay. That's okay. I highly respect them, and I know that they. It's not that they're wrong or I'm right, or it's just that they have a different interpretation of it, and I understand that, and I am perfectly okay with that. It doesn't affect me in any way. I tell people all the time. People know I'm a Republican, but I have great friends that are Democrats, and we get along wonderfully. We just don't talk politics. Or if we do, we know that it's just our politics. And then once that's over, it's over. I love them to death. They're still great friends of mine, and they always will be. The person doesn't change. Their politics doesn't change the person. I don't care what they believe that way. They're still the same person. And that's how I deal with people. All right, anyway. So that was a lot of rambling, 6 minutes in, to talk about paralleling. We're going to talk parallels today. And it'll be a long episode, so straddle in. I'm not into doing a short episode, so if you can't make it to the end of it, all right, well, probably shouldn't have made it this far. So let's talk paralleling for a second. When we look at the paralleling rules in the code, and we're going to use the 2017 code right now, we're not going to talk about the 2020, changes some things around a little bit. We're going to talk 2017 because it is what it is. It's what we have now. It's what we're enforcing now. If you go to 310.10h, those are the rules for paralleling. Of course, when we talk equipment grounded conductors, we're also going to go to 250 because that's important, because that's where we're going to get some demands that we have to be placed on our equipment grounded conductor applications. But we're going to start in 310.10h for parallel. So the 310.10h1 is your general rule. Okay, so when we're paralleling, what are we really trying to do? Well, when it comes to phase conductors or neutral conductors, the rules allow us to parallel in order to obtain, instead of running one larger conductor, we're going to run smaller conductors. Now, the code reminds us in 310.10h1 that whether we're using copper, aluminum, or copper-clad aluminum, each phase, polarity, neutral, or grounded circuit, okay, and we're not talking equipment grounds here, shall be permitted to be connected in parallel. When we say shall be permitted, that means if you want to run them full size, go for it. You're getting the option to run it in parallel. Now, what does parallel mean in 310.10h1? What does it mean to me and you? Well, it means that I'm running multiple conductors, at least 1 aught and larger, and I'm connecting them electrically, joining them at both ends. Because what I'm doing is I'm replicating one conductor. Basically, it's like a bunch of large strands that would make up a one large conductor. But when we break it down into multiple sets, then we might have as many as 4, 5, 6, or even more of phase A, phase B, and phase C that run. And all those A's come together. And it says right there in 310.10h1, it says electrically joined at both ends. So that means they come together to serve a purpose, a common goal. And what is that? Well, it allows the current to divide evenly on all of these phases. All of these sets, like A's or B's or C's. It allows them to divide. So what we're doing is we're paralleling phase A, phase B, phase C, for example. Now, if the links are different, characteristics are different, then there's a calculations that we can do to tell you actually what the current would be in proportional on each one of those phases and things like that based on the length and, again, additional impedance and all that. Not really the episode today. We'll cover some of the characteristic applications, but I just kind of throwing you out there something to think about until we get to the conclusion at the end. Okay, so I just want you to hang with me here. So we parallel phase conductors, neutral and grounded conductors, in order to get additional capacity. And then, of course, there's certain things that we have to do that make sure that those parallel conductors are going to divide current properly, and that there's no difference, so that we know that all of the characteristics in the effort of what we're doing, paralleling, doesn't change the properties of each one. Okay, each phase. Okay, so we're going to run 1 aught and larger. Now, one thing to remember is that we do have applications where the phase conductors, where the parallel conductors could be smaller than 1 aught. So we do have some exceptions to these rules. But when we talk about the general rule, we're just going to keep it at 1 aught and larger. But let's again jump really quickly to the equipment grounding conductor, because you're going to notice that 310.10H1 doesn't contain the term equipment grounding conductor within it. Yet many people are going to read into the rest of this language as the equipment grounding conductors have to be connected, okay, electrically joined at both ends, because of a reference back to 310.10H or what it says in 310.10H2. But I don't want to get to my opinion yet. I just want to talk about it a little bit. You can form your own opinion, okay? There's one thing to tell you how to pass an exam, and there's another thing to tell you how you're going to apply it in the real world. So today is not exam. Today we're talking real world applications. All right. Now, in this concept, you're running these parallels, there has to be some characteristics consistency. So when we just talked about the equipment ground, it states right in 310.10H5 that where parallel equipment grounding conductors are used, okay, they shall be sized in accordance with 250.122. And we all know that 250.122 sizes that equipment grounding conductor based on the size of the overcurrent protected device that's ahead of the circuit. So if it's one circuit conductor or one set, then you size the overcurrent device to protect those conductors, and you size your equipment grounding conductor based on whatever that overcurrent protected device is. That's what 250.122 says. Now, when you do paralleling with the phase conductors, for example, usually means you're trying to get greater capacity. Okay, so just an example. Let's say one conductor can handle 200 amps, but if I take 5 of them, then it can handle 1,000 amps. But it's 5 separate conductors brought together and connected together, and you have certain characteristics it has to meet so that the current will divide evenly on all of those sets. Okay, so that's what we do. So there's some characteristics that we have to meet so this takes place. That takes us to 310.10H2. Now, I'm going to read it because it's important for our discussion about the equipment grounding conductor as well as equipment bonding jumpers. And so we kind of want to read it. It says, conductors and installation characteristics. Again, 310.10H2. Says the paralleled conductors in each phase, polarity, neutral, grounded circuit conductor, equipment grounding conductor, or equipment bonding jumper shall comply with all of the following. So we've got 5 things here that we have to meet. Now, the first one says be the same length. Okay, so all the phase conductors have to be the same length. All the neutral conductors have to be the same length, those that are running parallel, if you will. And equipment grounding conductors, for the most part, all have to be the same length. Now, we know that 250.118 of the National Electrical Code gives us a list of all the different type of equipment grounding conductors. And just to kind of throw this out there, as we're talking about the first one, EMT, for example, is listed as an equipment grounding conductor. The typical installation, you can go on any YouTube channel, you can go on the internet, you can search for the installations. When you look at those, you have, if you have multiple sets and they're running raceways, then they typically are, the raceways are of different lengths. Okay, so they're basically, as you see, it kind of fans out and it goes out concentrically out into the different lengths. And so there's no real way that if you run all these raceways side by side in a neat fashion, workmanlike fashion that all of us are familiar with, that all of those raceways are going to be exactly the same length. It's just impossible. Now, it might be a case where they go straight down 90 over and then straight up. Okay, maybe they are the same length. But the normal applications that we run out into a building, out into the drop ceiling area and run them around, they fan out, and so theoretically the one on the outside is longer than the one on the inside. I mean, it's just physics, right? It's just the way it is. But the National Electrical Code allows us to use that as an equipment grounding conductor, and they are not the same length. So of the methods that we use, other than the wire method, Any of the other methods, rigid, intermediate, EMT, things like that, they cannot be the same length in all occasions, yet they are called upon to be used in parallel. All right, so just throwing the obvious out there as we make a discussion. So that's an example where the code tells me in 251.18 that I can use an EMT as an equipment ground, but it doesn't necessarily meet the rules to the letter of 310.10H2. It does not. Okay, so kind of just we're setting the stage. I'm throwing that out there. Now, with conductor links, we can account for the length, whether it's the phase conductors, if we run a wire type equipment ground, because we can take up the distance. And maybe we go to the furthest lug from that raceway and put all of our phases that are in that way. And so theoretically, we're going to have the same length of conductor. So if you're determining the length for a pull and you're running parallels, I would always choose the farthest raceway. The raceway is going to require the longest run, which is thus the longest conductor, and use that throughout all of the raceways, even the shorter one on the inner. And then I'd have to figure out how I take up the space with those conductors and how I route them inside of the equipment in order to make sure that I keep all of those conductors the same length. That's what the code says. Easy to do that, possibly. I guess your room that you're working with. When you're dealing with the phase conductors or the grounded conductor, neutral conductor. Not so easy to do with the equipment ground if it's using the raceway. Okay? So that's the first one. The next one is consists of the same conductor material. Okay. So again, we're talking about each set. So all A's, all B's, all C's consistent. So all of A's could be copper. All of B's could be aluminum, that kind of concept. But we want to have consist the same conductor material because what we're saying is the phase conductors in each phase, okay? Each phase, not all. So I'm not beholden to have phase A be copper, B be copper, and C be copper. It's A can be copper, B, all the B phases could be aluminum, that like that. Probably not done that way, but I'm just saying that's what the code says. Okay, and we're okay with that. This also would hold true, as you'll see, a little bit later when it comes to raceways, the consistency, because here we're talking about conductors and installation characteristics. And some people would say, well, your example earlier of EMT doesn't fall under H2 because that's a raceway, and it's really going to fall under H3. Okay. That may be your argument. And then that's what this discussion and this podcast is all about, however you want to build it. But to me, it clearly states in H2, the parallel conductors in each phase, polarity, neutral, grounded circuit, equipment grounded conductor, and equipment bonding jumper. It doesn't say only of the wire type. Okay? So you want to assume how you want. That's perfectly fine. I'm not here to tell you one way or other. I'm just reading you the code. The next one would be very consistent with conductors only of the wire type. Would be the application where it says, number 3, it says be the same size in a circular mill area. Okay, so 250 kc mill, consistent through that set. All A's, 250 kc mill. Now the difference again, if I'm doing copper for the A and I'm doing aluminum for the B, then all of the B would be the same size in circular mill, so that phase is consistent. Okay, that would be each phase is consistent with that circular mill area. Okay, obviously you don't want to parallel them up different because again, different sizes, different resistance. Chapter 9, Table 8, we can sort that out. And reality is current won't divide evenly, and you could have more current traveling on one conductor than the other. And theoretically, if you do the math, it could be more current traveling on one than the actual conductor can handle. So we don't want to have a premature breakdown or things like that. So you have to take all those things into consideration. So size plays a role. So once you size something, usually all of the conductors that are in that phase are going to be the same size. Okay? And as we know before, it's going to be 1 aught larger. At least, without applying any exceptions to the rule. So then the next one we get at is item number 5. And again, we're on 310.10H2. We're talking about conductor and installation characteristics. Number 4 says have the same insulation type. Okay, so if phase A, all of them were THHN, then phase B, they all could be XHHW, and phase C could be THHN again. Okay, you know what I'm saying? So as long as you're each phase in that set, then you're okay. So A, B, and C, then, you know, as long as that one phase, A, for example, is all THHN, then you're okay. That means phase B could be something else. Okay, that's what it's talking about. We're trying to keep the characteristics of that phase in this conversation. Okay, and that also applies to the neutral, like it says as well. So now, the other thing is that, again, this all applies as well to the equipment grounding conductor and the equipment bonding jumper. Okay, so you could have this, have the same insulation type. The only thing funky about that is that you obviously could have an equipment grounding conductor that is not insulated. Some cases it's required, but again, have the same insulation type. This is a general statement that's covering phase conductors, but since equipment grounding also lists in here, we know that the equipment grounding conductor is permitted under 250.122 to be insulated, covered, or bare. Okay, so we have a little leeway. I mean, we have things that again, it's not altogether black and white, and it depends on your situation. You have to use good judgment and to do that. Okay. But that's kind of the gist of what we're dealing with. Now, here's the last one that I want to address. Since we know that 1, 2, 3, and 4 doesn't always apply to everything. Again, there's no way EMT could be matched up in here, even though people say that's covered under H3. All right, well, we're talking characteristics of parallel, and if it's being used as an equipment grounding conductor, then you've got two situations here. You got one being used as an equipment grounding conductor, right? But then you have one that's being used and giving you some raceway rules. So I think they both apply. So when it comes to this one, we're looking at H2.5. And here's the one that creates most of the controversy, and is what our topic is going to be today a lot, is it says be terminated in the same manner. Okay. Understanding when we say be terminated in the same manner, many people are going to look at it two ways, and it's going to be the topic of our discussion today for the most part, is termination of not only the phase conductors or the grounded conductors, but also an equipment grounded conductor. Now, there's two camps here, and you know what? I'm not here to argue either camp. I'm more than happy to give my opinion, and I will. Obviously, I'm very opinionated. But let's look at this. Many people will say that because it requires in H1 that when the conductors are running parallel, that they have to be electrically joined at both ends. Okay? That's to create one conductor. That is for division of current. That is a limitation. It says 1 aught and larger. Okay? But we all know that it also says installed in accordance with H2 through H6. And H5 is the one that tells us, oh, by the way, the equipment grounded conductor can be smaller than 1 aught. Okay? So there's a lot of people that say, Paul, you can't add equipment grounded conductor to H1 because of the 1 aught and smaller. And I'm like, no, it's kind of an exception to the rule down here under item 5. So I don't, even though it's not an exception, it's a fact. It's right there in the code. So we kind of get there from there. So maybe the language could be massaged a little bit on it, but maybe there's a reason why it's not in there. So let's talk about it. H2.5 says be terminated in the same manner. Okay. Two camps here. One camp believes terminated in the same manner means that when you have paralleled equipment grounding conductors, that they have to come to the same common location, maybe on a quad lug if it's a set of 4, or a set of 3 lugs on the same bus bar, right there grouped together, because it's replicating electrically joined at both ends. Well, again, H1 doesn't say that. And H1 is the one that gives a reference. So there's people that say, Paul, it's just a given. It's consistency. We've always done that. I get it. And I, as an early apprentice, an electrician, and learning the trade, always did it that way. However, as I got further on, and people say, well, Paul, we're here to be consistency. No, I'm here to teach you the code. You're there to interpret it your way and work with your inspector. I'm telling you how it reads. And I have it from very high authority who agrees with my position here. I mean, very high, and I won't go into the names. But let's say it this way. Be terminated in the same manner can mean a lot of things to many people. You could mean terminate in the same manner if I have a lug, and it's just a compression lug, let's say, that I terminate all of my EGCs into a compression lug onto a conductive body that has a low impedance fault current path capabilities of 250.4. And that could be the enclosure, that could be the bus bar, it doesn't matter. The fact that I terminated it on the same types of lugs with the same either mechanical or compression to a conductive body, whether it's the frame, whether it's the bus bar, all bonded together, it's irrelevant. And that's a camp that some people are in, because when they say be terminated in the same manner, that doesn't say anything to me or to many people about grouping them in one location, because we're not trying to electrically join them at both ends. Now, theoretically, they're joined at both ends. That's true, because it's conductive medium to conductive medium. So yes, they are. Now, that might be a problem if, let's say I was paralleling those equipment grounds, which incidentally, the code doesn't allow me to actually parallel them. So there's two different trains of thought here. When we're paralleling equipment grounding conductors based on 250.122F, we're running them in raceways because we're getting rid of inductive reactance. There's an old Kaufman study that shows that if you move the equipment grounds away from the circuit conductors, that it creates enough inductive reactance that can cause the inability for the potential for that equipment grounding conductor to allow it to carry enough current to trip an overcurrent device. I get it. And then some people will say, yeah, but even when you parallel them that way, Paul, you're still dividing the current. And I'm not disagreeing, because current is going to travel, fault current is going to travel on all available paths, not the paths of least resistance, all available paths, proportional to the impedance, because we're talking AC, the impedance of that path. So yes, they will travel. But I quickly explain to people, I get you. I understand that. However, there's a reason in the National Electrical Code that we size equipment grounding conductors to the full size in every raceway. We do not parallel them out in the sense of me and you know paralleling, whereas we're doing it for a reason with phase conductors, because we need to get more current. And so if we go with multiple conductors, we can reduce the size of one big conductor down to smaller ones. And we tie them together at both ends because we want it to replicate one conductor. It's kind of like all the strands in a single conductor, how they're all tightly done together in what we call a length of lay. Well, we're doing the same thing with all these different sets, say phase A, because we want to replicate it so that current will divide evenly and we can get the most out of those conductors. Well, when it comes to the equipment grounding conductor, even though the current will divide on all these equipment grounds that are coming back, because they're all connected together at the metal enclosure that's bonded, we got to remember that we're not trying to do any division of current here. We're trying to clear an overcurrent device. So we're not dividing up the equipment grounding conductor, and we don't have the provision in the code that allows me to parallel it in the sense that I'm trying to do it in order to be able to get more current out of something that acts like a single conductor. We size each one of these EGCs full size. So each equipment grounding conductor on its own should be able to clear an overcurrent protected device. Now, if current does divide, who cares? Because they're full size in each raceway. You with me? So under that theory, there's a lot of people, and I respect it, that say, yes, Paul, but the codes say must be terminated in the same manner. Well, I personally will say that that's the way I did it for years, and I might still do it that way. However, if I'm talking theory in the concept, and I'm also been confirmed by many people, so I'm not a crazy person here. You can believe what you want. Other educators can disagree. But I have some pretty heavy hitters that'll say, you're absolutely right, Paul. And nobody really thought of it that way. And that's why you go read books on it. Nobody talks about it. In fact, they don't even talk about it. They say it has to be done in parallel because they believe that it says be terminated in the same manner. When we say same manner, my interpretation of same manner is to the metal enclosure. It's the same manner as all of them. All of them must be terminated to the same enclosure. When I say same manner, I think they all have to be the same type of lug for characteristic purposes. I don't necessarily say they all have to be terminated in the same location, but they do have to be terminated onto the conductive medium that serves the effective ground fault current path and meet all the rules in 250.4, okay, for grounded systems. So at the end of the day, the question is, if I have a ground fault condition in any one of these raceways, am I going to clear the overcurrent device, regardless of where I terminate those equipment grounded conductors onto the metal enclosure, the bus bar, as long as it's all bonded together? Is it going to clear the overcurrent device? And the answer is absolutely. We're banking on it. We're hoping that's what happens, because that's why we size the EGC full-sized based on that overcurrent device. We're not trying to parallel it in order to say, instead of running a 4-aught in each raceway, oh, can I get away with a 2 in each raceway? And when I add up the circular mills, it's equivalent to a 4-aught. That's not what we're doing. We're doing that with phase conductors and neutral conductors, and we do all these rules to make sure that the current divides evenly so we can get the best bang out of our buck for running in parallel. That is not what we do. So it's a strict reading of H2.5, where some people want to say same manner means that once you pick one manner, they all have to be in the same manner. Okay, if that's what you feel, do that. Do it. But in reality, that's not what I read, and that's not what a lot of people read. And so that's the reason why I do podcasts, and some people are upset that I'm doing this podcast, and some people are not. They're like, well, you're bringing light to a situation that most people didn't think about. And there's a lot of electricians that do this, and they'll say, well, gee, Paul, I do that all the time. But did you ever really think of the concept of when we're talking about it? Now, again, if the intent was to be paralleled and electrically joined at both ends, then it would make some mention of it, in my opinion, in H1. Now, some people say, well, it doesn't, because you can parallel equipment grounds smaller than 1-aught. That's true, but we're not paralleling them for the same sense as why we do it in H1. We're doing it for different reasons, okay? And they're still full size. Even though they might be less than 1-aught, it's still full size based on the overcurrent device. And we cover that in H5. So that's that. So that's the conductor characteristics when you're paralleling. And yes, it doesn't say equipment grounded conductor there. And I agree, again, it's hard for every scenario to meet everything in 1 through 5. And I challenge people to send me an email and prove to me that there is a benefit to require me to connect all of those equipment grounds together on a single lug, on a quad lug or tri-lug or wherever it would be. Some people say it's for consistency. Some people say it's just the best way to teach the apprentice. I disagree. Let's teach the apprentice what the practical method. So that's what I'm here to do. And that's what I'm talking about. And you make your own mind up. Again, I'm not here to sway you either way. I'm just giving you the facts. And people say that's not facts. That is facts. I'm reading H2.5 differently than you might read it. I'm not considering it terminated in the same manner. If I wanted to do that, I could say be terminated in the same manner and location. It didn't say that. It's the same manner. I torque it the right way. I use the right kind of lug. I connect it commonly in the same manner to what? A common lug or a bus bar or a metal enclosure that I met the requirements of 250.8, whether it's one of those different lugs. Now, it says one or more options in 250.8. I can use a mechanical lug, drill and tap, but they all are connected to the same what? Conductive body that's effectively serving that effective ground fault current path return. So they're all tied together. So that to me is the same manner. Now there's some that will argue that no. If you take one to the bus bar, they all got to go to the bus bar. Okay, if that's how you want to do it, it's fine, but I got to ask you something. Again, if you didn't, would you still expect the equipment grounded conductor to serve its function and actually clear the overcurrent device? Because these are full-sized. We're not bringing them together to replicate a single conductor. We didn't reduce the size of the equipment grounded conductors in each raceway in order to achieve literal paralleling. Just because we're running side by side, we call it paralleling, but we are not paralleling equipment grounded conductors to do it the same way we would parallel phase conductors. Okay, so enough of that. So the second train of thought is that they believe that means that they all have to come together in one common location, whatever, but that's not how I get it. Okay, now move on to the raceways. Because so that's when the EMT is used as a equipment grounded conductor, because that's what it says in 250.118, okay, of the types that you can use. Now, let's talk about raceways or cables. When they all run in separate cables or raceways, the cable or raceways with conductors shall have the same number of conductors and shall have the same electrical characteristics. Well, they don't. If you run them normally how we run raceways, they actually are concentric. They go out. And so the outside one is going to be longer than the inside one. But nobody says anything because it just is what it is. Because we know that EMT and all those metal raceways can carry fault current. It's very effective. And it works. I'm a wire guy, but it works. We've been doing it for decades. Okay? It says conductors of one phase, polarity, neutral, grounded conductor, or equipment grounded conductor shall not be required to have the same physical characteristics of those in the other phase. We talked about that. A can be all A's alike, all B's alike, all C's alike, that type of thing. Okay? However, all of the equipment grounded conductors have to be similar. And I think it's hard to do that with the EMT that are installed traditionally how we would do it, but nobody says anything about that. Okay? So I hear a lot of people say common sense. I get it. And we know we can't follow the exact letter in a lot of cases of H2 with all these characteristics. But we do the best we can. There's some things that we can do. When the conductors are run in each phase, we can make sure they're the same length because we cut them all the same length. All right, for that phase. Same material, easy to achieve. If we're running all phase A in copper, all phase B in aluminum, that's fine. Just know what you're doing. Same size circular mill, easy to achieve. Okay? If you're paralleling for 400 amps and you run all the conductors of the same size, you simply parallel it out. You don't have the mixing of sizes in the circular mills, okay? All phase A, the same size conductor. All phase B, same size conductor for whatever that phase would be, okay? Insulation type, that's easy. That's easy for conductors, okay? Either you're using THHN or XHHW, one or the other. Keep it simple to that phase and you're not going to have any problems. Terminate in the same manner, okay? Well, terminating in the same manner when you're dealing with conductors can be an iffy. Because what are we talking about? Terminating at the same location or terminating in the same manner? That is connecting to the conductive medium with the same type of lug and the same either compression or mechanical, keeping it all consistent. I don't necessarily believe it means it all has to be done in the same location. You can agree to disagree. That's fine. I got my own share of haters out there, so it don't matter to me. I don't care. But when you're doing things like EMT, it's very hard for it to be the same length or rigid or intermediate. Okay? And it reiterates that in H3 as well. So just keep those things in mind. Okay? And of course, we get down to H5, and I'm going to skip H4 because that's just ampacity adjustments. Conductor installed in parallel shall comply with the principles of 310.15b3a. We know that. So we don't need to deal with that because B3A is simply talking about the number of current carrying conductors, and we have plenty of videos and podcasts on making those different types of adjustments when you have more than 3 current carrying conductors. But this goes to show you that does apply, and you're going to have to make an ampacity adjustment because it is heat, and it's hard to dissipate when you have over 3 current carrying conductors, so you have to think about your application. Now, 5 is equipment grounded conductor. And so I've kind of explained 310.10H, 1, 2, and 3, and so 5. 5 gives us the direct rule that says, where parallel equipment grounded conductors are used, they shall be sized in accordance with 250.122. Well, we get that. We're going to size it based on what? The size of the overcurrent device. I get it. And it's going to be full size. It also says that sectioned equipment grounded conductors smaller than 1 alt shall be permitted in multi-conductor cables if the combined circular mill area of the sectioned equipment grounding conductor in each cable complies with 250.122. So this is sectioning. A lot of this is done in MC cables as well. And it's going to allow you to section it. Okay? Now, let's go back because I made a statement earlier And I probably should clarify, because I know there's somebody out there who's saying, whoa, Paul, H5 didn't say anything about smaller than 1/0 because H1 deals with that. Well, first is first. H1 is dealing with phase conductors, polarity, neutral, and grounded conductor. It is not dealing with equipment ground. Some people say if I added equipment ground here, then it would be saying that the equipment grounds could not be smaller than 1/0. And technically, H5 doesn't say that. Okay, good point. But the point I was making is if I added equipment grounded conductor to H1 and it says that they only be sized as 1/0 and larger, then we can get there by going to 250.122F. And let's do that. So now I go to 250.122F. And at that point, the haters are writing down little stuff down saying, well, Paul said earlier that it's covered in H5. Look, I've helped thousands of people pass exams and whatnot, and I still have my haters. I usually say they're just jealous because they don't have the cojones to actually go and put themselves out there. They like to sit in the background and think that they help people, and they don't. So let's go over to 250.122F1B, because we're talking about multiple raceways. It says, and here's what it says in the code. If conductors are installed in parallel in multiple raceways, wire-type equipment grounded conductors, where used, because again, we know it could be the raceway, shall be installed in parallel in each raceway, period. It doesn't say anything about the termination. It's just installing them in parallel. And the reason we're doing this is keep all the conductors together so we can reduce the inductive reactance that takes place by separating the equipment ground. There's a great Kaufman study that's out there that explains this, and some of the tests he did where he moved the equipment grounded conductor away from the circuit conductors and all this type of stuff. And the inductive reactance increased, and it really inhibited the ability of the overcurrent device or the amount of current during a condition of fault current or current that's traveling on it to be reduced and then possibly not be able to clear an overcurrent device. So you want to keep all of them together. I get it. In the raceway, makes perfect sense to me. Okay? Now, it goes on to say, the equipment grounded conductor installed in each raceway shall be sized in compliance with 250.122 based on the overcurrent protected device for the feeder and branch circuit. It says metal raceways and auxiliary gutters in accordance with 250.118 or cable trays complying with 392.60B shall be permitted as an equipment grounded conductor. Okay? So, this is our first part of it. Now, when we're dealing with this application, we need to understand what the purpose of what we were doing, why we were doing what we were doing with running these equipment grounded conductors. Now, I will concede one thing, that the fact that we don't have equipment grounded conductors listed in 31010H1 is what permits me to have my EGCs smaller than 1/0. I will admit that. So for the 2020 code, we could have clarified this rule and made it a little clearer, although people say it's clear. And I will say in 2020, we did not add equipment grounded conductor to 310.10H1. So that's intact. Nothing changes there. Here's the problem. In the 2020 code now, we're actually changing 250.122F1B, and instead of saying installed in parallel, which is what we're trying, like it says in raceways, it's now going to say connected in parallel in each raceway. Now, I'm going to argue that doesn't mean anything different to me. That statement doesn't mean connecting as how we do the end termination. We're going to let 310.10 deal with that. But it still says, it'll say, instead of installed in parallel, it'll say connected in parallel. Well, the reason that gets a little muddy is because if you go look at the application for 250.122F2, which is multi-conductor cables. Now, this is a scenario where we changed it in the last cycle, and it's new here in the fact that it's new in 2017 that says, look, if I want to use an MC or a tray cable where the equipment grounded conductor is sized based on what would be typically the overcurrent protective device size for that single cable, then it is adequate. But when I want to run a standard off-the-shelf cable, and now I want to run it in parallel, typically it means that the reason we're running conductors in parallel is so that we can get more current. We're just taking that value and dividing it by 2, for example, if it's 2 sets, and then finding a conductor that can handle half of that. Each one of them can handle half of it, and together they handle the total amount. Okay, so if I needed 400 amps, at 400 amps, I'd divide it by 2, so I'd look for a conductor, each one that can handle 200 amps. That's the concept. Together, if they're meeting 310.10H1, they're electrically joined at both ends, they replicate a single conductor, and I get the benefit of using the 200 amps for the one and 200 amps for the other. Together, they can handle 400 amps. That's why we parallel. All right, so all the characteristics have to meet the same because we're treating both of these and we want it to act like one conductor. If one conductor is longer than the other, then the current's not going to divide evenly and one can heat up more than the other depending on the amount of current. And so we follow those characteristics. Okay, so we get that. Now with a cable, because the conductor is only sized for one, when we put them in parallel, we either have to order a special cable, okay, and we have to get an increased size equipment grounding conductor. So the whole rule here was to allow me to be able to use an off-the-shelf type of MC cable or tray cable. And what I would do is, and I'm going to read you what it says here. Okay. It says, 2A says, if multi-conductor cables are installed in parallel, the equipment grounding conductor at each cable shall be connected in parallel. Okay, so we have explained to people that what you're doing is that if you're doing it in a cable tray and things like that, I'm using cable tray as an example, you're going to run an equipment ground. If you want to parallel MCs with the standard size EGC, you're going to also run a full-sized equipment grounding conductor alongside those cables. We really don't say how far away, but we know that Kaufman said we probably should keep it pretty close. And so we want to run it beside it. And then when we get to the termination point, they all have to be connected together. So you're going to connect your full-size EGC, and we're going to connect it to those paralleled EGCs. Now, we're not allowed to do that under the normal rule, but we can do this for cables like this multi-conductor cable application. So basically, it is acting in parallel, and you would need to connect the conductors at both ends so that that current will divide evenly. Now, granted, you're going to have the full-size equipment grounding conductor, so that should suffice in itself, but we want to tie them all together so they act as one, and there's an importance to try to keep that equipment grounding conductor that's full-sized as close proximity to the conductors that are in the cable assembly. So we don't really have any parameters for that when it comes to separation and distance, and we didn't reflect to Kaufman's and look at some of those type of things for those rules, distance, and I think I submitted something for that or something, but I don't think it passed. At the end of the day, we can see why we might do that for a cable, because we are using what we consider smaller EGCs in a parallel and connected in parallel application. Based on all we've discussed now, and all that we know, if we're running multiple raceways and we determine that there's really no reason because it's a full-size EGC, in the 2020 code, new language is being added to 251.22F1B that gets rid of the term installed in parallel and changes it to connected in parallel. So my theory is that during the time when we were changing things and we were trying to get the table 250.122 changed to be more kind of mirror what the cable manufacturers do, and it would have changed some sizing and things like that, I think that was in counterpart working with F1 and all those things were being worked together. And I'll be honest with you, I think that the mentality was we do want them connected in parallel because we're trying to follow the same thing we would do for cables and sizing and all that. But we've established that nothing changed in 250.122 for the 2020 cycle. We didn't change it. Everybody thought we were going to change the table, but there was not evidence there. We didn't have any data Issues came up about motors when we have to size the overcurrent larger, and if we size the EGC to that, was that going to be necessary? And we didn't take certain things into consideration. So at the end of the day, we kept the table. I personally believe that to me, it's a mistake to have F1B change that term installed in parallel to connected in parallel. It makes sense for F2 because we explained why you would want to treat those two that are smaller size. And why are they smaller? Because you're connecting them in parallel, literally connecting them in parallel, because you're looking for division of current. Because they're undersized based on what the overcurrent is. That's why we have to run a full size beside it, maybe as a fail-safe. You get me? So I get it. But we create problems here in F1B because we know that we're not trying to divide current. We know that there can be many interpretations of H25 that does not say they have to be in the same location because we're not needing to electrically join them at both ends. Although now with the word connected, it implies that. And I think that's a wrong move. And we're going to be stuck with it in 2020. So that's just my opinion. Okay. Again, there's a lot of people out there that will say, well, they are parallel, Paul, because they're both connected to the metal conductive medium at both ends. I get it. They are in parallel. They're all in parallel. All equipment grounding conductors that are run with raceways and everything at each end, if they're all bonded, they're running in parallel. I get it. But that's just by happenstance. That's how we connect things together. The reality is, do we need to have the equipment grounding conductors connected in parallel to clear an overcurrent device? Now, there's some people that give me this theory of what ifs. Like, well, what if this comes loose? Or what if that comes loose? Or what if this can... You know what? I cannot get into the concepts of what ifs. The code is not a what if code. It's a minimum safety standard. If you install it right, you terminate it on a lug that's compliant with 250.8, you clean off the any of the paint, we're all assuming you make the proper termination. Again, we can't fix stupid. So we want skilled people are using this code book, right? It says at the very beginning of this code book, it's only for use with those of skill. Okay? I mean, if you go back and read it, all the way back to the actual scope and purpose, 90.1a, practical safeguarding. The purpose of this code is the practical safeguarding of person and property from the hazards arise from the use of electricity. This code is not intended as a design specification or an instruction manual for the untrained person. Let's not get away from that. So I ask you, is there a safety concern if I don't electrically join, which is what people want to imply 310.10 H25 means when it says same manner? If that's what you mean, and we know that EMTs can't comply with everything here. We know that the links can't comply. So if I'm asking you that, and they didn't put the language in there, can it clear an overcurrent device as long as it's connected to the metal enclosure that's bonded? Everything is bonded together. We're okay to do this. And the code is very specific in other things. For example, 250.24, it's very specific that the grounding electroconductor make connection to the grounded conductor. We don't physically make it to the grounded conductor, but we can make it to the bus that's common with the grounded conductor. That's specific language. It's telling us what to do. And then it goes on to say, well, if you have a main bonding jumper and then you come to it and then you're using the wire type, then I'll let you take that GEC to the metal enclosure, which if you have a main bonding jumper, all of this should be tied together anyway. So we have allowances and we're very specific. On here, we don't need to be so specific. I'll give you another great example. 230.70A1. Outside or nearest point of entry, yet jurisdictions around the country will let you go 3 feet, 4 feet, 5 feet in. So they'll allow service conductors into the building. If you want to follow the literalness, is that a word, of the code, then it would be outside or a nearest point. I mean immediately, the moment that it pokes through the wall. That is a fact. Now, with that said, any jurisdiction could look at it the way I look at it and they have the final rule. They could say, I don't care. As long as you're using the same type of lug, you're compressing it in the same manner, you meet all the characteristics, you connect it to the same common bonded enclosure, it wouldn't matter to me. It's still going to do its job. And what's the job? Clear the overcurrent device. As long as you meet one of the termination methods in 250.8, one or more of them, I can have multiple options. I can have lugs on a bus. I can have a lug on the panel. It's done all the time. And are you expecting that breaker to trip? Absolutely. You're expecting that breaker to trip. Okay? So, kind of understand that. But I don't think I'm a fan of the change in 2020. But I'll support it. But I don't think that it actually means connection at the end. Yes, it means that in F2 because we know about the principles and what has to take place and what we're trying to do. But in F1, I don't necessarily going to buy on that, whether they change it to connected parallel, because I don't think that the principles of current flow, the understanding of it, what it's trying to do, what the overcurrent's trying to do, and anybody that cites the Kaufman study has to understand that that's the reason we're running them in Raceways. But once you get to the actual enclosure, it's pointless because we're just trying to clear the overcurrent device. That's all we're trying to do with it. Will current divide on all of the equipment grounding conductors? Absolutely. They're all connected together and they're all going back to one location. Remember, current's going to take all available paths, not just the path of least resistance, but it's going to be proportional to that path. In our luck, all of the EGCs are full size. So it's irrelevant. It's irrelevant. So if they were paralleled out and they were smaller in size, such as what could possibly happen in F2, in 250, 122 F2, which is why we connect them in parallel. The language that's in 250.122 F1B is going to be confusing and makes it more confusing and is a reason for my podcast. Okay? I don't believe that. I think that it was the intent that all these other things were going to change, and this was kind of changing along with it. Or I believe that some people may believe that 31010H25 literally means connected, electrically connected and joined at both ends to function properly. And I'm a fundamental believer that's just not going to happen. I'm open to your concepts. I'm open to your opinion. You can send me. If you want to convince me otherwise, I'll be the first person to come on here and do a podcast and say I was wrong. I promise. So you can be a purist and say that you believe this what the code says. And then I'm talking 2017. It gets muddier in the 2020. But again, I don't think that purpose holds true why you're doing it. I do believe you install them in parallel, but I don't believe you connect them in parallel. And then there's the other part of me that say they are connected in parallel. As long as they're connected to that metal enclosure that's all bonded, whether you go 3 of them to a lug and 1 of them to the same type of lug on the drill and tapped enclosure, that they are connected in parallel. You see what I'm saying? Because it's not going to matter at all. Okay? Not going to matter. We're not trying to divide current evenly. We're not involved in that. We don't care for that overcurrent to trip. They're full size. Now, at some point, we start paralleling like we do with multi-conductor cables, then we've got rules to cover that. But when we're dealing with this, it's unnecessary. Totally unnecessary. It will clear the breaker. Okay? So, anyway, that's my rant for today. I hope you got something out of that. Form your own opinion. You can agree with me. You can disagree with me. I don't really care. You can thumbs down all you want. I don't care because I don't show them. So you can be a hater, or you can jump on the bandwagon and say, you know what? It makes sense, man. And I can tell you right now, some heavy hitters in the industry, and y'all would know who they are because their name are plastered everywhere. And I'm not talking about other educators, maybe some that are in the South. I don't even not talking about that. I'm talking about people that are integral with the code as far as being on different code bodies and things like that, but are on the same bandwagon. But they're like you and me. You have to submit a change in order to get things changed. The first thing that I would recommend was to change the wording for 2023, change the wording in 250, 122 F1B, back to parallel in Raceways, because that's what you're doing. I agree with that. I agree. The next thing that I would change, and it's just me talking out loud, is, and I will submit this, hopefully, and I sit on Code Panel 5, so that will be an interesting debate. And again, some people agree to disagree. That's fine. You can always disagree. I don't care. But my next thing would be to change and clarify 310.10 to make it clear. And the easiest way to do that would be down in H5 to state in there, okay, not required to be electrically joined at both ends, but are required to be joined to a common, maybe a common grounded component in compliance with 250.4 or something of that nature. I'm still working on the language. Some people would say, well, why don't you just, those that want it to be in parallel, it can prove that it needs to be in parallel. Why don't they add it to H1? I don't think that's going to happen because of that 1/0 and smaller application. Equipment grounded conductors can be smaller. You go to table trays and it tells you blunt that it can be smaller. So I don't, it's whatever's based on the overcurrent device, and that could be smaller if you were running them. It could be smaller than 1/0. So I get that. The other thing would be H2. If you wanted it to be terminated in the same manner and same location, then you need to submit it and say be terminated in the same manner and location. Look, I'm okay. You just got to have consistency. If you want to read it that way, that's fine. But when I see same manner, I don't read it that way. Call me a fool. There's many people that will. But I can tell you there's big people above me that believe the same way, that that's not what it's saying. As long as it's an electrically conductive body, the enclosure, that as long as you use the same type of lug and you terminate it, then you're okay to terminate it there. It's not a problem. It's not going to be an issue. But we have to clarify, and that's what my interpretation would be, terminate in the same manner. Some people will say same manner says if I terminate one on the bus, that I have to terminate them all on the bus. Okay, that's your rigid way of interpreting it. If you say if you say that the be terminated in the same manner means the same type of lug, okay. The same type of lug, same compression or mechanical, whatever it be, onto the conductive medium that complies using a lug or termination type with 250.8, one or more options, onto a metal enclosure. Okay. Then and it's bonded properly, then they're all terminated in the same manner. What's the same manner? They're all terminated to a bonded equipment. Okay. However you want to interpret it is okay with you. I'm just bringing that out there so that you can debate it and get an understanding of it. Again, I have had people that disagree with me, and that's fine. If you want to connect them because you think that's exactly what the code says, I disagree, but that's okay. We can agree to disagree. It's all good. But that's not what I see. Okay? When I see it, terminated in the same manner means terminated to a lug to a conductive body, whether it's the bus bar or the enclosure. If they're all bonded together, they are. And when I read the 250.122F1B that's coming into 2020, connected in parallel, I'm going to go with the same theory. Okay? I'm going to go with the same theory under that, is that it means that as long as I connect them to the conductive body at the end, that they are theoretically in parallel. Now, if somebody wants to come up with the definition of parallel, it says that all conductors have to be bonded together. Okay. And they say, well, Paul, that's just a theory. Okay, well, I'm going to go real quick to definitions and see if I see that. Let's see here. Panel board is the first P. Stops at purged and pressurized. Okay, so I don't see parallel in there. Well, Paul, it's common sense. Whatever. I disagree. Okay? Installed in parallel means put them in raceways because we know why we do that. We know what we're trying to achieve. When it comes to the end and it starts to terminate, that's where it gets all muddy. Why is it necessary? Not needed. Anyway, that's my opinion. You can believe otherwise. Hopefully you've learned something new, some new insight in here. Love the comments. Trust me, if you got hater comments, you're not going to be seen. I don't deal in haters. if you have a constructive comment that can bolster your opinion of why it's important that they be installed together, then bring it. I'm listening, but I haven't heard it to date, and have more people that agree with me than disagree with me, right? So anyway, that's our mission for 2023. It's too late for 2020. Sorry, didn't pay much attention to that and the significance of it. It's just like anything. Sometimes your mind, they're focused on other things, and you didn't think about it, and you do things sometimes that are unnecessary, and why will we do this type of thing? So it's on my radar now. So again, that's going to be my mission for 2023, is to put a lot of study into this and explain why they don't need to be paralleled. It should be obvious, but they are paralleled in the raceway, but not at termination, because it's unnecessary at termination. Again, my opponents to this would say current does travel on each one of the EGCs. I'm not doubting that. And they will say that it's got to divide. It does not need to divide proportionally even. That's why they're full size. Full size. Okay? It's going to clear the overcurrent device either way. So what benefit are we achieving? We know why we do it for phase conductors. We know why we do it for neutral conductors, because we're trying to get more current out of smaller conductors, thus we parallel. And because we keep all the characteristics, current divides evenly, and we don't get a breakdown of insulation on each one of the conductors based on an unproportional amount of current traveling on it. We reducing inductive reactance by keeping all those conductors together in a raceway. Once it gets to the enclosure, they separate to go to terminals. We get it. Okay? We get it. But it's unnecessary, and that's my opinion. So, folks, till next time, stay safe. Look for a video to come out on this at some point. But that's my podcast ranting for today. I appreciate all the listeners that we get on this podcast, all the haters. Hey, trust me, there's a lot more people that send me love than they do hate. So you're just living in hate, buddy. I'm living in praise. I love it. So everybody, till next time, stay safe. God bless.
Every day, the future's getting closer. Every day, the future's looking bright. Every